Continuing to work on elimination, looking at worksheet 834. As we're looking at these systems and we're going through our steps, as we get to step number 2, it's not going to be possible to multiply the one equation in the system to create an opposite coefficient with the other. So we're going to have to go to step 3, which states that we're going to have to multiply each equation in the system by a different number in order to create the opposite coefficients that we need. The easiest way to do that is to simply multiply each equation by the coefficient of the other. Now, that doesn't sound very clear, so let me give you an example. So let's say I'm looking at 3x and 7x. Now, I cannot multiply 3 by an integer and get a negative 7, and I cannot multiply 7 by an integer and get negative 3. So step number 2 in our solving the system doesn't work, multiplying just one of these numbers to create the opposite. So we're going to go to step 3, and we're going to have to multiply each of these numbers by a different number to create opposites. And the easiest way to do that is to simply multiply each coefficient by the other one, and just to change the sign of one if I need to do that to create opposites. So what that means is I need to take this 3 and I need to take this 7, and I'm going to multiply this 3 by the other coefficient 7. So when I multiply 3x by 7, that's going to give me 21x. Now, to create the opposite, I'm going to need to multiply this 7 by the other coefficient 3. Now the 3 times the 7 will still be positive, so I just need to make that a negative 3, and by doing that I'm going to get a negative, that's not a very good negative sign, a negative 21x, and therefore I have the opposites, and when I add those together that is going to be 0. So I had to multiply each of these numbers by a different number in order to create opposites, and so that's the method that we're going to use to solve the systems on this worksheet. So let's take a look at example number 1 here, and again, it doesn't matter which variable you choose to make opposites, you're just going to have to multiply by different numbers anyways. I guess the one thing you might look for is maybe look for the smaller numbers because you're going to be multiplying by those numbers, so working with smaller numbers and multiplying makes it easier. So as we go through our steps then, we look for equations in standard form, which we have. We look for opposites. The x coefficients are not opposites, the y coefficients are not opposites. I can't multiply by a single number to get 6, and I can't multiply by a single number to get 4, so I can't make the x's opposite. Same thing for y, so we're going to have to multiply each by different numbers. So the easiest way to do this then is to multiply this first equation. If I'm going to, let's say, eliminate the x's, I'm going to multiply this first equation by a positive 6. So I'm going to go through and multiply all these numbers by a 6. Okay, so when I do that, that's going to give me a negative 24. So to create the opposites, I'm going to multiply the second equation by a negative 4. So I'm still going to multiply by this 4, but make it negative, so this negative 6 times this negative 4 will give me a positive 24. So when I multiply both of these equations by different numbers, the x's will be opposites. And again, remember, that's all we're trying to do is to create opposites. Okay? So now because I'm multiplying them by different numbers, I'm going to have to rewrite each equation, and so again I want to line them up, so I'll rewrite them underneath. So taking the first equation, 6 times negative 4 is negative 24x, 6 times 5 is 30y, and then negative 12 times 6 is negative 72. Okay? Then taking the second equation and multiplying it by negative 4, we get a negative 4 times a negative 6, which is a positive 24x, and there are my opposites. The negative 4 times the 3 is the negative 12y. And then negative 4 times negative 18, that's going to be a positive number, and that's going to be 18 times 4, let's see, that's 40, and 32, that's going to be 72. Alright, so I have the two equations changed now. I now have my opposites, so now I can go ahead and draw my and add these equations together. So the 24 and the negative 24 add up to 0. 30 minus 12 is 18. So it's going to be 18y. And 72 and negative 72 is 0. I am then going to multiply by the reciprocal of 18, or divide by 18. So these 18s reduce, leaving me y, and then 0 times anything is just 0. So the y value of my answer or solution is 0. Now, just like we've been doing before, we can now go back to any of the equations, either the original 2 that I have or the 2 new ones that I got after multiplying by that number, and I can substitute y into any of those and determine the x value from there. So I'm going to go back to, let's say, this second equation right here, and I'm going to put y in and substitute the value for y into that one. So that's going to give me negative 6x plus 3 times the y value, which I now know is 0, is negative 18. So simplifying my equation, I have negative 6x, 3 times 0 is 0, and then I have negative 18. And then I'm going to go ahead and divide by negative 6, which is the same as multiplying by the reciprocal. So that's going to be 1 over negative 6. So the negative 6 is reduced to 1, leaving me 1 times x, which is x. And then the 6 goes into both 6 and 18, and then I have a negative over negative meaning positive, so I end up with a y value of 3. So the ordered pair 3, 0 is the solution to my system. So nothing different in this elimination process. It's just we have to multiply both equations by different numbers to create the opposites that we need in order to eliminate that first variable. Okay, looking at number 3 on the worksheet, again we want to go through our steps. We look for equations in standard form. They are. We look for opposites. The x coefficients are not opposites. The y coefficients are not opposites. We look to multiply one equation to create opposites. I cannot multiply 4 by an integer and get 5, and I cannot multiply 5 by an integer to get 4. Same thing for the y values, so I'm going to have to multiply both equations by different numbers in order to create these opposites. Because both the x's are positive, I think I'll just go with those first, but again, it doesn't matter whether you choose to eliminate the x's or the y's. So I'm going to multiply this top equation by the coefficient of this other equation of 5, so that's going to be a 5 here on all of these. And then I'm going to multiply this second equation by the coefficient 4. Now I need this to be the opposite of what I'll get up here, so if I leave 5 times 4 positive 20, I'm going to need this to be a negative number, so I'm going to make this, I'm going to multiply here by a negative 4 then in order to create my opposites. So multiply this by negative 4. Okay? Again, we're creating two new equations, so we'll rewrite them down here so that we can then add them up after we've changed them a little bit. So 5 times 4 is 20x. 5 times negative 3 is negative 15. And then 5 times negative 1 is negative 5. So that's my first equation. My second equation, negative 4 times 5 is negative 20x. There are my opposites. The negative 4 times the negative 4 is a positive 16y. And then negative 4 times 0 is 0. So by multiplying by different numbers, I have created my opposites. So we'll go ahead and add these equations together. So the 20x and negative 20x is 0. 16y minus y is a positive y, and then negative 5 and 0 is negative 5. So I have my y value of negative 5. To determine the x value, we can go back again to any of the equations that we've been working with, either the original 2 or the 2 new ones that I created. Because I multiplied by the same number, those are equivalent, so we can substitute into either one. I'm going to go all the way back to the first one this time, so I'm going to substitute into this one, substitute our y value into there. So rewriting this first equation, I have 4x minus 3, and then I have a y value of negative 5, so we substitute that in. It's negative 1. Then we use our solving equation steps. We first have to multiply. We then want to add like terms if we have any, which we don't. So we're going to then isolate the variable or the term we're solving for. So 4x here. 15 minus 15 is 0. And then negative 15 and negative 1 is a negative 16. And then we're going to divide by that 4, which means we're going to multiply it by the reciprocal of 4. So the 4 is reduced, leaving me x, and then that 4 is divisible, and that's 16 divisible by 4. So that leaves me a negative 4 over 1, so x would be a negative 4. So the ordered pair negative 4, negative 5 is the solution to the system, arrived at by using the elimination method. Looking at number 5 on our worksheet, we'll go through our steps. We look for the equations to be in standard form, which they are. We look for opposites. We do not have opposites for the x's or the y's. Can we multiply one equation by a number to create an opposite? 3 cannot multiply 3 by an integer and get negative 5, cannot multiply 5 to get a 3. Same thing for the y, so we're going to have to do step 2 where we're going to have to multiply by different numbers in order to create opposites. This time let's go with the y's just because we've done x's on the last two. So these are already different signs, so that's kind of nice. I don't have to worry about that. So this coefficient's of 4, so I'm going to multiply my first equation by the number 4. And then I'm going to multiply the second equation by the coefficient of this, which is a 5. And again, I don't need to make it a negative 5 this time because the signs of these are already opposites. So once I get the numbers to be the same, the signs will be different, and I'll be ready to go. So we'll go ahead then and multiply this first equation. So we have 4 times 3, which is 12x. Negative 5 times 4 is negative 20. And then 4 times 1 is a 4. And then the second equation, 5 times negative 5 is negative 25. 5 times 4 is a positive 20. There are my opposites. And then 5 times 7 is 35. So I now have my two equations that have the opposites coefficients. So we can go ahead then and add these equations together. So negative 25 and 12 is a negative 13. 20 and negative 20 is 0, so that variable is eliminated. And 35 and 4 is a 39. We then are going to divide by negative 13, which means I'm going to multiply by that reciprocal, which is 1 over negative 13. And then we'll just go ahead and reduce these fractions. So the negative 13 and negative 13 reduce to 1. 1 times x is x. And then 13 goes into 13 one time and into 39 three times. This is over a negative, so I have 3 over a negative 1, which is negative 3. So my x value is a negative 3. To determine the y value, I can go back to the original two or even the two new equations that I created. It does not matter which one I'd like to do. It doesn't matter which one I use. I can use whichever one I would like. And let's see. I'm going to go back to the second equation here. These numbers in these new equations are kind of big, 12s and 25s. I don't want to have to multiply by those, so I go back to the original ones. So the second one here, so I have negative 5, and then I have my x value, negative 3, that I substitute in. And then I have the rest of my equation, plus 4y is equal to 7. Then we simplify our equation, multiplying this, so that's going to be positive 15 plus 4y. My pen doesn't like that downstroke for some reason. We're then going to isolate the y term because we want that by itself. So 15 minus 15 is 0, leaving me just the 4y. And this is going to be negative 8. We then are going to divide by 4, which means we're going to multiply by the reciprocal of 4, which is 1 over 4, and then we're going to reduce. So those reduce to 1, leaving 1 times y, which is y. 4 and 8 are both divisible by 4, so dividing that by 4. So that leaves me a negative 2 over 1, so y is a negative 2. So the y value of my solution is a -2. So the solution to this system is the ordered pair, -3, -2, using the elimination method. Looking at number 7 on our worksheet, we'll go through our steps. Are the equations in standard form? Yes. Do we have opposite coefficients? The x's are not opposites. The y's are not opposites. We look and see if we can multiply one equation by a number to create opposites. I cannot do that with the x's, and I cannot do that with the y's, so we're going to have to multiply both equations by a different number to create our opposites. Again, we can choose x or y because the signs of the y, are already opposite signs. One's positive, one's negative. I'm going to choose to make those opposite. So I'm going to multiply the first equation by the coefficient, the y coefficient of the second one, which is a 4. And again, because the signs are opposites, I don't need to worry about the signs. They're going to end up being opposites anyways when I multiply by the number. And then the second equation, I'm going to multiply by the coefficient here of the first one, which is a 3. So multiplying those by the coefficient of the other is going to create opposites for me. So we'll multiply these equations, creating our new and equivalent equations. 4 times 3, that's going to be 12x. 4 times 3 is going to be 12y. And 4 times 0 is 0. Then for my second equation, 3 times 5 is 15x. 3 times -4 is -12. There are my opposites. And then 9 times 3 is 27. I now have my opposite coefficients that I need, so I can go ahead and just add these equations together. So 15 and 12 is 27x. 12 minus 12 is 0. The y variable is eliminated. And 27 plus 0 is 27. Okay, then we're going to multiply by the reciprocal of 27, or to divide by 27. So we're going to divide by 27, which is multiplying by the reciprocal. The 27 is reduced to 1. 1 times x is x. And then the 27's reduce over here to 1 as well, so I end up with an x value of 1. To determine the y value of the solution, I can go back to any of the two original or the two new equations that I produced and solve my equation from there. I'm going to go to this new equation here that I created here and use this one and substitute in the value of x. So rewriting this equation then, I have 12, and then the x value is a 1 that I just determined. And then I have the rest of my equation. So now I just have the equation with y, so I'm just going to use my steps to simplify. So 12 times 1 is 12. 12y is 0. I would add like terms if I have any. I don't, so I can go to isolating the term I'm solving for. So I'm isolating the 12y because I'm solving for y. 12 minus 12 is 0 plus 12y, so that's just going to leave me 12y, and that's going to be -12. We're then going to divide by that 12 or multiply by its reciprocal, which is 1 over 12. So the 12 is reduced to 1, leaving me 1 times y, which is y. This 12 is divisible by 12, and so is this, so I have a -1 over 1, so that gives me a y value of -1. So the ordered pair 1, -1 is the solution to the system. Okay, this is our final example for the 834 worksheet. Again, we continue to go through our steps. Are the equations in standard form? Yes. We look for opposites. The x coefficients are not opposites, and the y coefficients are not opposites either. We look to see if we can multiply one equation by a number to create opposites. I cannot do that with the x's, and I cannot do that with the y's. So I'm going to have to go to step 3 here, multiplying by different numbers to create my opposites. Again, because the signs of the y coefficients are already opposites, I'm going to choose to make those opposites by multiplying each equation by the other coefficient of y. So the first equation I'm going to multiply by this coefficient of y, which is a 3. So I need to multiply every term by a 3. And then the second equation I'm going to multiply by the coefficient of the y variable in the first, which is a 5. So I'm going to multiply by a 5. And again, I don't have to worry about the signs because the signs of the y's are already opposites, so they will end up being opposites when I multiply by these numbers that I've chosen. So the first equation will multiply everything, so we're going to have 3 times 3, which is 9x. 3 times 5 is 15y then, and then 3 times 3 is 9 over here. For the second equation, I have 2 times 5, which is 10x. I have 5 times negative 3, which is negative 15y. There are my opposites. And then I have 2 times 5, which is 10. Because I now have opposite coefficients for the y's, I can go ahead and add these equations together. So 10x and 9x is 19x. The 15 and the negative 15 is 0, so the y variable is eliminated. And then I have 19. And then I want to divide by 19, which means I multiply by the reciprocal of 19. So multiplying by the reciprocal, then reducing that fraction leaves me 1 times x, which is x. The 19's over here both reduce to 1, which leaves me 1 over 1. So 1 is the x value of my solution. To determine the y value, we can go back to either the 2 original equations or the 2 new equations that I created to substitute in the x value of 1, and we can determine the y value doing that. So let's go back to this second equation here in the original, and we'll put in our x value there. So we're going to have 2 times the x value, which I now know is 1, minus 3y is equal to 2. So multiplying those together, I get this. Then we're going to isolate the y term because that's what we're solving for. 2 minus 2 is 0. I still have then negative 3y. 2 minus 2 is 0. I then am going to multiply or divide by the reciprocal of negative 3. The negative 3 is reduced to 1, leaving me 1 times y, which is y. And then 0 times this fraction is just going to be 0. So the y value of my solution is 0. So the ordered pair 1, 0 is the solution to the system using elimination. Okay, so those are almost all the different types of things you probably run into with elimination. We got one more worksheet to look at, 835. We'll do that in the next video.